Hi, this is Miss Erickson coming to you to show you how to use your manipulatives that you've made on balancing equations. Um, so, so far, you should have a pile of atoms in front of you. They can be Legos that you happen to have in your house, or they can be the little pieces of paper that you made. For this example, we're going to need 4 carbons and 8 sulfurs for you to do this activity. You can either do this and follow along with me, or you can just watch and complete your first part of your notebook page, which is now in Notability. You'll notice that we're not having science notebooks anymore, and everything will be in Notability now. Um, so I just want to show you how I want you to do this, and I really encourage you to actually physically use your pieces of paper and or Legos when you're at home to do this activity, because it really will show you a deep understanding of what goes on in a chemical reaction to turn your reactants into products and what it means to be balanced. Um, so what I'm going to do is I'm actually going to start by bringing some reactants out of my pile of atoms. So I've got carbons that come in molecules of only one. So they're atoms. And they come by themselves. They don't bond with anything else. The carbon just kind of hangs out by itself. But you'll notice that sulfur comes in packages of 8. So I can't just come and grab a sulfur. I don't want that one. I want this one. I can't just come and grab a sulfur and be like, oh, I need another sulfur. I'm going to just grab one. I need to bring them in the packages that they come in. So in this case, it comes in a package of 8. So I'm going to first make a molecule of sulfur. And I'm actually going to physically attach them together to model that I'm making a molecule. Because as you know, molecules are bonded to each other, and we actually going to snap them together like our Legos like to snap together and make them into a molecule. So now I have an S8 here. And the reason I have this little volcano here is because this reaction, taking carbon and sulfur 8 and turning it into sulfur disulfide, happens inside naturally in a volcano. It happens other places, but volcano is one place that it happens, so I picked a volcano. Okay, when you guys do your reactions on your own, you're going to have the places that these reactions occur in as well. All right, so my reactants, I've got my first ingredients. I don't really know how many I'm going to need, but I'm going to put them in my volcano in these little packages. Get this one out of the way. Actually, I want that one there. Just kidding. Move that one out of the way. Um, and I'm going to put them in these packages. Okay. And I'm going to bring them over to my products. So now products has all of these things. Volcano, you can stay back. There we go. Um, but in this case, now I can break up in the packages. So I don't have sulfur 8 anymore. So I'm going to break the bonds and I'm going to make an atom with my carbon and 2 sulfurs. Okay, so I have a carbon and 2 sulfurs. I have one of these, a carbon and 2 sulfurs. Problem is I have all of these sulfurs left over, and that can't happen. I got to take care of them somehow. So I'm going to need more carbons. So I'm going to come over to reactants. Reactants is going to come and grab a um, carbon and give it to the products. And products is going to be like, awesome, I have what I need now. I can make another carbon disulfide package. But products is saying, hey, reactants, you're not done yet. You need some more. So we're going to grab another reactant. We're going to throw it over there to the products. And we're going to make another. These things don't cooperate with me. Another carbon. There we go. Another carbon disulfide. I still have 2 of these left. So I'm going to need another carbon from the reactants to give to the products and finally make another carbon 2 sulfide. Okay, so let's look at what we did here. We ended up having to make 4 molecules, 1, 2, 3, 4 of carbon disulfide. We only needed one of these, and we had to ask these carbons, 4 of them, to come on over to help us make these. So let's figure out what this looks like in our notebook page now. So in your notability page, I gotta get used to saying that, we've got your equation here with the coefficients missing. But we know what those coefficients are because we just figured it out. We only used one of those big sulfur 8. Let me fix something here. Do, 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 do. Order. Order. Okay, there we go. We only used one of these sulfur 8s. We had that really big red thing. Okay, we only need one of those. Problem was is we had so many sulfurs to deal with over here that we had to bring in 4 carbons. We had to bring in 4 carbons. And I'm going to fix my problem here. There we go. That should fix my problem. And then we ended up with 4 of those molecules. Remember? We ended up with 4 of these. 1, 2, 3, 4. So that ends up being 4 of these. We had to ask reactants for 4 carbons, but we only had 1 sulfur 8. All right. And so now what we're going to do is we're actually going to show in a drawing form the physical model we just made. But first we need a key. So our sulfur was red. So I'm going to fill in my key that sulfur was red. And my carbons were blue. So I'm going to fill in my key that my carbons are blue. You get to pick whatever color you want, either whatever you colored your pieces of paper or whatever Legos you could find in your house. If you have some other blocks other than Legos, use those. Be creative. Okay? All right. So now I want to see your drawings here. We ended up with 4 carbons. Those carbons were not bonded together. They were all by themselves. So we're going to show them separate boxes, not sitting next to each other. The sulfur 8 was bonded together. So we're going to show that these are all bonded together. And we're going to show that by having them sticking next to each other. I don't care what shape you use. There is a specific shape molecules come into, but you don't really need to know that. So let's just show that they're all stuck together and that they're bonded together. Okay, so this would show a molecule. This is 4 different carbons. Okay, now we're going to show it for my products. So 1 carbon, 2 sulfurs, and we made, let me fix that problem. Yep, copy. I'm just going to paste that a bunch of times because we made 4 of those. That did not work the way I wanted it to. Let's try it again. Paste. Just going to show them that they're a little bit separated. And 1 more. We made 4 of them. So we're going to have 4 different molecules drawn out there. So this is how you're going to model it when you're going to do 2 more equations. For 4, you're going to do 3 more. You're going to do it for photosynthesis, which is the equation that we use to take sunlight and turn it into a piece of sugar for life to use as then food. Either the plant uses it for themselves or we're going to use it for something else to eat it and use that sugar package. We're also then going to do it for a separate equation, which is the cellular respiration equation, which takes that food package and turns it into energy that the organism can use, called ATP. If you want a 4, you're going to do the chemosynthesis equation, an example of a fairly simple chemosynthesis equation on how chemotrophs use chemical equations to get energy as well. So hopefully this helps you figure out how to do it. Again, if you have questions, email me or post them in the assignment in the discussion. I will try to see as many as I can. And hopefully we'll get conferencing and Schoology up going, and then we'll be able to have some more interactive conversations. But this is the start. Good luck.